So, hi guys, welcome to High Entropy. Today, I'm sounding like I don't know. Okay, so hey guys, welcome to High Entropy. It's day 82 of DSA learning. Yesterday, I was feeling so sleepy, then that I wasn't able to focus, so I stopped the stream in between. But after that, like I took a little break, maybe 30 minutes, 40 minutes. I took a nap, and after that, I again watched the video and solved that first problem because the goal wasn't to stay on a stream, was to solve the problem. And sorry, but I wasn't able to solve the problem. Okay, so next day, next beginning, and let's begin without wasting time. So let me transition it. I think, oh my god, actually I'm sharing my, no, it won't be so. Yeah, so yeah, let's begin. Thank you so much, and I hope now you can see my screen. So let's jump into take you forward, and we are right now we are solving matrix chain multiplication. Yeah, it's tricky one, but it's simple also. MCMDP. So I solved the first problem. Let me see what is the second problem. Matrix chain multiplication bottom up DP. Okay. So I think I already solved it. So, but let's solve it again. You can see it, right? Even I think they have linked it same with the same. But let me do it again. So it will be like a kind of quick revision. Okay, so max 4 types are allowing. Okay, so thing is simply we need to create a table. So let's take length of it. Length in nums will be the length, and table will be something n cross n. Because here, if you notice, like we are taking two things, I and j, and I and j can vary between. If I talk about it, I. Okay, the thing is simply we are controlling. MCM is simply nothing but you have given an array, it's array, okay, and what needs to be done, and it's nothing but array is representing dimension. So if the size of array is n, that means total there are n minus 1 matrix. So let's say it is 0th, first, second, and so on, n minus 1. So this one, if array of I will start from 1. Just imagine. So this is one matrix, and you can get the dimension of it. Array, or you can say A1 matrix. A2 is nothing but dimension of A2, this one and this one, you can calculate the dimension. So AI is nothing but array of I into I minus 1 into array of I. So this represents dimension of array I, not array, sorry, matrix I. Okay, so exactly what we are doing here. So in case of so simple approach is simple. Here what you are doing, basically you are asking, okay, if I am this is my array, so here I to j, let's say these are the matrix I to j. Okay, now you want to split it into two matrix. Imagine you are splitting it into two parts. So what exactly we are doing here, we are splitting it into two parts at k, and we are trying out all possible options for it. So for I to j, this is the length of the complete you can say different matrices that are possible between I and j. and then you are taking k, and k can vary between, k value can vary between I, here I is representing this, so j, and k can go up to I to j minus 1. You know why j minus 1? K is basically, you can think of like k is basically a point where you are breaking it into two halves. Okay, so here if you say, if you will take k as j, then the problem is it will be like it will split I to k one matrix and k plus 1 to j. But if you notice, if you already taken till k, then there will be empty matrix, and that is invalid scenario, right? So that's why what we are doing, k can vary between I to j minus 1, and so this is one is value of k can be between these two. So we are solving based on this only. So what exactly we are doing? Simply just imagine you are taking different, so you have given two things, I and j. This is nothing but boundary or different matrices that are possible between these two, I and j. Okay, now you are taking some, you are trying out all possible k, option of k, and then you are splitting it into two matrices, and you are asking solve for it, and whatever the result that you are getting from these two plus third, it will be like here this element, suppose you have given 2 cross 3 into 3 cross 5, and whatever happens between, when you are multiplying them, this is the one, this one, and this one out of this. So the same way, whatever is at array of I minus 1 into array of k into array of j. So this is the cost plus solve 1 plus solve 2, and this way you will get for a particular k. And now you are going to try out all possible values of k. Try for all possible values of k. Hmm. Hmm. I just wanted to see if it is working or not. Yeah, so we are going to try out all possible value of k, and so between like for particular I and j, all possible values of k, try for all possible values of k and get the minimum. And that is option here. So I already solved it using recursion. Now thing is, I need to solve it using bottom up. So what exactly we are going to do? So what you will do, if I greater than equals to j, it will return 0. So what I'll do, I will simply fill the array with zeros at starting. Now you will use two loops for I in range. What exactly we are doing? So it can go between n minus 1. We will start filling from bottom to top, and there is a reason behind it, because if you know, simply there are three conditions. If I greater than equals to j, return 0, and second thing is simply what exactly you are doing. You have to up things for k in range, you can say I to j. Okay, And what exactly you need to do? K in range I to J, and you will say temp or result equals to max. Okay, now you'll do one thing. You are going to ask, there are two options, whatever K you are choosing, so it will be like table. You will ask, okay, find the solution for I to K and plus result equals to plus, I mean, yeah, so this will be option 1 table plus option 2 table, and here you will say K plus 1 to Z. Okay, these are two options, option 3, or you can say where we are calculating. So table, not table, array of these are the options. Okay, and we need to minimize the cost, so min of uh, array 1, minimum, find the minimum, and it will be somewhere option 1 plus option 2 plus option 3, and whatever the result that we have so far. And this is what we are going to do here. Yesterday I asked Cloud to generate a script because I wanted to download to improve my spoken English. So I just wanted to watch Modern Family, and I downloaded it because I don't want to use some third party uh, application to download it. So I just wanted to use a script, and it downloaded very quickly. It means think it took almost 20-30 minutes, 40 minutes, 5 GB data. Though my internet speed is not that good, so I would say. So here I'll do 0 for underscore in range n, and for underscore in range n. Okay, now for I in range, here what you are doing? I can be between n minus 1, and it can go up to 0, no, till 1. So if you take till 0, that means it will consider till 1 and minus 1. And for j in range, definitely n minus 1. I just have confusion here. I can be between 0 to n minus 1. I mean n minus 1 to 0. J can be between, I and j cannot be equal. Right. If both are equal, then it will be 0 only. And you know one thing, yeah, j should be bigger than only. And here I'll do for k in range I to j minus 1, I to j minus 1 it will represent, and result equals to float of INF. So this is max value, and after that OP1 you will say table of I and 2k and option 2, table of k plus 1 to z. Option 3 is to array of I minus 1 into array of k into array of j. Finally, you will say result equals to mean of result and op1 into op2 into op3. Written, not written. At the end you will say for table of I and j is equals to result. Written, finally you are going to return table of, basically you need I will be 1, j will be n minus 1. As usual I do same mistake. Oh, it's like a pattern. If you are making similar mistakes. Made mistake somewhere. Somewhere I think I'm doing some mistake. Basically what I did is to 0. I everything is 0. What did you do, brother? Great. Okay, minimum cost to cut the stick. Oh, well, this one seems interesting one. Hey Cloud, just shut your mouth. Given a wooden stick of length n units, the stick is labeled from 0 to n. Okay, given an integer array cuts. Given a wooden stick of length n units, the stick is labeled from 0 to n. Length n units. The stick is labeled from 0 to n minus 1 given an integer array cuts. Position you should perform a cut at. The cost of one cut is the length of the stick to be cut. Cost of one cut is okay. I did not get the question yet. Given a wooden stick of length n units, the stick is labeled from 0 to n. The stick is labeled from 0 to n. Given an integer array cuts, where cuts I denote the position you should cut from. Order of the cuts u is as u is. The cost of cuts in the label is the cost of one cut is the length of the stick to be cut. Change the order of the cuts as you wish. The cost of one cut is the length of the stick to be cut. The cost of one cut is the मुझे समझ ही नहीं आ रहा. Cut it. The cost of one cut is the length of a stick to be cut. The total cost is sum of the cost of all cuts. Sum of all cuts of the minimum total cost of the cuts. Using cuts order 1. Okay, so you are keeping. Okay, so cuts of high value will be at least 1. All integers in the cuts array are unique. Rod cutting problem. Using cuts order 1, 3, 4, 5 as the input leads to the following scenario. First cut is done to the rod of length 7, so the cost is 7. The second cut is done on a rod of length 6. Three, four, five. Just want to visualize how the value is changing. First, suppose you break the string into two, basically split it. Then length will be shorter, and it depends on how you are cutting. Accordingly, you can reduce the length. So when cut is done on the rod of length 6. Three, 5, 1, 4. So what are the options? I mean, I'm it's little tricky. So we have given cuts of 5, denotes you are cutting at the ith position. And now cost of the cut I is nothing but before I. Okay, so what can we do? Simply we have given our cost, not cost, but it is given cut. So to perform a cut, what I'll do, let's say you perform a cut at ith. Hmm. I mean, I just confused or what? So what I'm thinking, we have given cuts array and it has some values. Okay, so I mean I need to choose out of this which cut I want to perform. So let's say you choose, like, you perform the kth or cut at k. Out of this you pick one, and now you'll say, okay, I am I have performed at k. Now remaining one, you will ask it to get for the remaining one, for the remaining one from left, because this is like the k, you split it at k. So before k, whatever the length, and you will provide a cuts array, and here also you will provide cut array. And you know everything is unique, and these are nothing but indexes 0 1 2 3 4 5, something like that. So here you are going to check all the values again, you are going to test out, and you will again split it into some part, and you will ask, okay, this what is the k cut for this length, and at the end you will so basically what you will do for solve. Now what I'll do, simply If I equals to j, I greater than j, what does it mean? That means you already finished. There is no length available. And I equals to j, what does it mean? It also means you are at some particular position. You already covered everything. Now there isn't any length available. Else, okay, so you are doing this for k in cuts. Now for each cut, like whatever this is position representing position. I to k you are taking. So max. Now you will say C is nothing but the cost of cutting at k will be nothing but I j minus I. J minus I will be the length. A, B, C. Let's take example 1345. Okay, there will be various options. So let me do one thing. First I will solve it for, okay, we have cuts, we have n. I, self I and j and n and cuts. Y greater than equals to j greater than 0. Cost of cutting. Okay, so option 1, option 2, option 3 will be basically what you will do: option 1 and option 2 and option 3. Option 3. Option 3. What was it? Length of the existing. So j minus I. No if. And total cost will be result. Zero. Unexpected indentation. Huh? What is wrong here? Unexpected indent. Where is the problem, bro? अरे बहन चो क्या हो गया? इधर क्या कर रहे हो? सॉरी. Line 9 unexpected indent. Where is then? Hold on, bro. No, something I'm missing. Oh, something. Chadi budi, I will ask. I think my brain stopped working. Oh, submitted instead of. Wow. Segmentation fault. So return self 0 n minus 1. What does it mean? One minute. How much time I am just wasting time my time. 49 minutes fucking हैंगशॉट क्या कर रहा है? So bad. 1345. Let's say you started cutting at 1. Okay, this is the one. So what does it mean? How to check which one is already being taken? For example, if you are making cut at K, it should not be part of K. K not. Oh, it should not be K minus 1. Exactly what's wrong? You are taking cut at 1, let's say. Then what does it mean? So you will look for like okay 0 to 1 tell me, and 1 to 7 you will ask it to tell you. Okay, one thing I missed. If k value is greater than I, because for I you already sliced I and j that are already being chopped cutted at that particular length greater than I, and k less than j. नहीं बन रहा. Rod cutting problem. And जो कुछ rod cutting. Given a wooden stick of let's see. So you have 1, 3, 4, 5. I at a starting will be 0. You will say okay I'm taking 1. So I to k means 1, 0 to 1, and another one split will be n is like here 7. Okay, now you will say, okay, let me check for 0 to 1. Now again you will call for two splits. Okay, you will say 1, 3, 4, 5. So you will end up with like, okay, nothing is here. K greater than I, nothing matching, so it will end up 0 and J. What I'm thinking, but here we are retaining float I and F, so that's not acceptable answer. Some design flaw. I greater than equals to J. if it won't work, 14, 16. I'm getting minimum. Something is wrong. Let's do it.
Today we will be solving an interesting problem in partition DP, which is minimum cost to cut the stick. What does the problem state? The problem state, you'll be given a cut side and you'll be given a length of the stick. Now, what do you mean by a length of the stick? This is a stick of length 7. Now, we'll just write them down. This is how the stick looks like. Okay, this is the stick of exactly length 7. And this is first 2, 3, 4, 5, 6, 7. So, a length of 6, 7. Now, they're asking you to cut these at these portions. You can cut it at 1, you can cut it at 3, you can cut it at 4, you can cut it at 5. You can cut it as you wish. Okay, and find me the minimum cost. Very important. You find me the minimal cost to cut the stick. Okay, now you can follow any order. So what is cost? Cost is the length of the stick you're cutting. Length of the stick you are cutting. Okay. So if I start by cutting at 1, if I start by cutting at 1, what is the initial length of the stick? If you just write down the length of the stick, it's 7. So if I decide to cut at 1, the initial length of the stick is 7. So I do a cut at 1. So when doing a cut at 1, I will have a stick of length 1, and I also have a stick of length
6.
6. Okay. This is 1, 2, 3, 4, 5, 6. Length 6. Now if I decide to cut the length 3, where is length 3? Where is length 3? Length 3 is here, which is saying this. What is the length of the stick? Because this stick is no more connected to this. What is the length of the stick? 6. Still require cost of 6 now. And we decide to cut it here at 3. So now you will have a stick of length 1, a stick of length 2, and a stick of length, right, starting from 3, 4, 5, 6, 7. A length 4 stick. So now I say cut it at length 4. Where is length 4? This is 4. So what's the length of this particular stick? 4. So the costing that you require is 4. Now I decide that I'm going to make a cut here. So when I decide to make a cut here, I will have 0, 1. I will have 1, 2, 3. I will have I will have 3, 4, which is length 1, and I will have 5, 6, 7, which is somewhere around length 3. Perfect. So this writes properly. My bad. Let me write this properly. We will have 4, 5, 6, 7. So it will be of length 3. Next, I say cut it at 5. So if I'm cutting at 5, which is this stick length is of 3. So I'll be requiring cost of 3, and I'll cut it here. And I will have a stick of length 1. I will have a stick of length 3. I'll have a stick of length 1. I'll have a stick of length 1, and I'll have a stick of length 2. So this, when you cut at 5, was of length 3. So the total costing that you require is 7 plus 6, 13 plus 4, 17 plus 3 equal to 20. This is the costing you required if you went on by cutting it at 1, 3, 4, 5. The cost came out to be 20. The question states if you minimize this 20, I don't want 20 because it's a lot. I want to minimize it. So the question states minimize the cost. Okay. So what we will do is we'll go across and minimize it. So you can follow the cuts in any order. So in this case, if I cut it like 3, 5, 1, 4, like it was given to us as 1, 3, 4, 5, but I rearrange the cuts to say I'll first do a cut on 3, then I'll do a cut on 5, then I'll do a cut on 1, then I'll do a cut on 4. Okay. So okay, fine. So that means initially we had single cut at 3 with several given. 0, 1, 2, 3. We will also have a length 4. It was like 3, 4, 5, 6, 7. Okay. Length 4. I'm saying cut at 5, which is I'm saying cut it over here. So this stick is of length 4. So answer added will be the cost added will be 4. So after this, we will again have this 0, 1, 2, 3. Right? We will again have 3, 4, 5. We will again have 5, 6, 7. Okay. So we have made sure that we have done the cut at 5. I'm saying cut it at 1. So I'm cutting at 1, which is this. This is a length 3 stick. This is a length 3 stick which I'm cutting. So the costing will be this. So I'll be left out with 0, 1. I'll be left out with 1, 2, 3, which is of length 2. I'll be of 3, 4, 5, which is again of length 2. I'll be of 5, 6, 7, which is again of length 2. So the costing is 3. Next I'm saying cut it at 4. So I'm cutting at 4, which is definitely this. This is a length 2 stick. It's length 2 stick. So the total cost that comes up is 7 plus 4, 11 plus 3, 14 plus 2, 16. So I got a lower cost. I got a lower cost. You can try out all orders. And you see if you follow the order of 3, 5, 1, 4. This is the lowest cost that you'll get, which is of 16. Yes, this is the lowest that you'll get, is of length 16. You can't go lower than this. So how do you approach this problem? Because you will be given something like 1, 3, 4, 5. This is in cuts. You'll be given the length of the stick. So how do you start the approach? Because you can either start with 1 as the cut. You can either start with 3 as the cut. You can either start with 5 as the cut. So you have a lot of options to start. So can I treat this as a complete stuff? Can I treat this as 1, 3, 4, 5 as a complete stuff? I can. And then can I say, if I make a cut at 4, if I'm making a cut at 4 for sure, I can also start with 5. Or I can say I can also start with 3. So I know if I treat this as a partition, like if I treat this as an ing, like an entire array, I can say I can either start with 1, I can either start with 3, I can either start with 4, I can either start with 5. What if I start with 4? What if I start with 4? I know the initial length of the state. I know the initial length of the state is 7. So I'll add up 7 to the answer. How we will find this, we will get to know. But if I start with 4 for an example, I say I'll make the first cut at 4. Can I say I'm making the first cut at 4? The answer that I'll add is 7 because that is the initial length of the state. At least at the first step, the length will be the complete step. So can I say now I'm solving only these cuts and only these cuts. I'm solving only these cuts. Right? Like a 1, 3 and a 5. I'm just solving these cuts. Now, if I solve them independently, will this work? Solve them independently, will this work? Yes. Why? because it is sorted. Because it is sorted. Let's understand what this means. Now, if you have made a cut at 4, you know that you have something like 0, 1, 2, 3, 4 now. And you also know you have something like 4, 5, 6, 7 because you've made a cut at 4. So you've segregated them. No matter if you perform 5 at first or 3 at first, they won't matter because even if you're performing 5, it's nowhere connected to the stick. Even if you're performing the cut at 1 and 3, it's nowhere connected to the stick. The sticks have been separated. And why can you solve this sub-problem independently? And why can you solve this sub-problem independently? Because they're not connected. But if I just do one bit, I just do one short and change, and I say, I'll just change this test case to this. And imagine I was having something like this. And the right sub-problem would have been 5, 2. Imagine. This is the right sub-problem and this is the left sub-problem. Now you cannot solve them independently because this is dependent on this because this two, the two on the right will be over here. So you're dependent on the left stick. Thereby, it's very important to have it sorted so that whenever you solve a problem, sub-problem, they will not be dependent. You can just go over and see whether you're going to make cut at 4 or 5. You won't be dependent on this. You don't have to decide whether you want to make a cut at 1, 3, then 2, or at 1, 2, then 3. You will not be dependent. It's very important that you make sure that the array is sorted. Okay, that is something that you have to do. Now, how do you find the length of the sticks? Very important. So, let me just visualize it a bit. I'm having 1, 3, 4, 5. Okay. I know this is a partition that I'm solving. This is a partition that I'm solving. Okay, this is an entire partition that I'm looking to solve. I want to find how are these parts going to be the minimal ones. I'll just put in a 0 and the length of the stick, right at the left and right at the. I'll just put a 0 on the left. I'll just put the length of the stick on the right. Why do I do this? Imagine I'm making a cut at 4. I know I can make a cut at 3 or at 5 or at 1 anywhere. Imagine I'm making a cut at 4. But what is the cost? The cost is the length of that stick. In which 4 is. The cost is the length of that stick in which 4 is. That is for sure. How do I get this? I minus 1 cuts of j plus 1 rather, which is this j plus 1, minus cuts of I minus 1, which is this. 7 minus 0 is 7. This is the length of the stick. If I apply this formula, it will give me the length of the stick. I will show you why in future. So we have understood that this is giving the length of the stick. If I'm taking this guy at the first cut, then I need to solve this guy. So imagine this is at index. I need to solve this portion, this subproblem, which is I to index minus 1. I need to solve the right subproblem, which is index plus 1 from the right to the last. Because I did a partition of index, I solved it from I to index minus 1, this small partition, and index plus 1 to j, this partition. So I just took and cut, and I'll be solving these subproblems. And since they are sorted, they are independent. And since they are independent, I can just solve them independently and add up the answer with the current answer, which is this. So you might ask, how is this working? I'll show you after I write the code how is this exactly working. You'll get a clear-cut idea. But before that, let's start writing the code. So you've understood that it's going to be a partition like 1, 3, 5, 8 was initially given to you. You will just 1, 3, 4, 5 was given to you. You will insert a 0 at the front. You'll insert a length of the stick at the back. And if I write on the indexing, it will be like 0, 1, 2, 3, 4, 5. So it'll start off I from here and j from here, which you can call it as f of 1 or whatever was the initial length. Like whatever is this initial length was 4, right? Initial length was 4. So you just start off with 4. So that's what the initial partition is. So f of 1 I. So that's what the initial partition is. So f of 1 I comma j. Now I know I can start with this. I can start with this. Which eventually means I can take anyone as the first step. I can take anyone as the first step. So thereby what I say is okay. Now in partition DP, you know, because you're solving a portion, if it crosses over, there is nothing to solve. So you just return a 0, the cost will be 0 if there is no partition to be solved. I know one thing for sure. I can take anyone from I to j. And when I'm taking anyone, the costing that I'll incur is cuts of j plus 1. I've already showed you why, and I'll prove it again. This is the cut. This is the cost if I cut it at that index. And I have to solve the left guy, which is I of index minus 1. I have to solve the right guy, which is index plus 1 for sure. The left guy and the right guy is what I need to solve. Okay. And since I need the minimal cost, then I can keep it as int max. And I can just say minimal equal to minimal of mini comma cost. And at the end of the day, I can just return the mini. And I should be done. This is how the simple enough code looks like. What I do is, I take the current cut at any of the index, and then I go to the left subproblem, to the right subproblem, get it. For every index I get the cost and take the minimal of all the indexes. That is what I do. So I track all partitions and I return the partition that gives me the minimal answer. Okay. Coming back to this portion, which a lot of you probably do not understand. So let's take a bigger example just to make it clear enough. Okay, imagine this is the stick and the length is somewhere around 12. Imagine the length is somewhere around 12 and you're starting off by solving this portion of partition. Okay. So just for an example, imagine the first cut that you made was at 5. For that reason, the first cut that you made was at 3. So we're making a cut at 3. You know, the length is definitely, because this is I and this is j. the length is definitely 12 minus 0. So j plus 1 and I minus 1 for sure. That is for sure. But whenever you're making cut at 3, you are having a subproblem as 1, 2. This is your subproblem. And the right of it as the last cut was at 3 and this was 0. And this right subproblem will be 3, 5, 7, 8, and 12. And this will be the partition that you'll be solving. This will be the ij and this will be the ij over here. Now if you carefully observe, if you're making a cut at 3, you'll be of 0, 1, 2, 3. And the length will be 3. So again, if you carefully see, 3 because that was the last cut, and the last cut on the left was 0. So 3 minus 0 again gave you the length of the stick. Similarly, if you made a cut at 3, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, okay? So just write this 4, 5, 6, 7, 8, 9, 10, 11. 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 is the length. And if you again take 12 and 3, you get the length as 9. Because this is the last portion where you made the cut, and this is the right last portion where the cut was. So 12 minus 3 will give me 9. Imagine, I take this 5, 7, 8, and I see, I will do a cut at 7. I'll do a cut at 7. So I will have a left guy as 3, 5, 7. And this will just be the partition that I'll be solving. I'll have the right guy as 7, 8, 12. And this is the partition that I'll be solving, I and J. Now if you're doing a cut at 7, you are hypothetical. Yes, you're hypothetical left with 3, 4, 5, 6, 7, which is a length of 4. And this is 7, 8, 9, 10, 11, 12. We'll just write it across 7, 8, 9, 10, 11, 12. 1, 2, 3, 4, 5. So again, if you see, 12 minus 7 gives you the length 5. 7 minus 3 gives you the length 4. So this is the reason J plus 1 and I minus 1. Because if you know the left last cut, right last cut, and if you just subtract it, you get. Yes, that is how you get easily the length. So I hope I was able to explain you why this and why the left subproblem and the right subproblem. Once you've understood this, I think this becomes a very simple cakewalk partition detail. So now what I'll do is I will just go back to the code, okay, cost to cut a chocolate, and